This is the Pre-Calculus Chapter 8 review. So let's get started here. Didn't leave enough room to show work there, so I'll do these on a separate sheet of paper. Number one, we have the square root of 2 sine x minus 1 equals 0. And our domain for these is 0 to 2 pi, not including 2 pi. Okay, and so we add 1 to both sides. Square root, square root 2 sine x equals 1. Sine x is 1 over the square root of 2, and that is a triangle we know. In the first quadrant, it would be 1, 1, square root 2, so that would be a 45-degree angle, or pi over 4. And then the other angle would be in the second quadrant, over here. This is 2 pi over 4, so this would be 3 pi over 4. And those are the only two answers. Number 2, we have the absolute value of the cotangent of x equals 1. So to simplify that, or to use the definition of absolute value, that means cotangent x equals plus or minus 1. And so that 2 is an angle we know, and because it's plus or minus, it's going to put it in all 4 quadrants. And so this would be 1, 1, square root 2. So we're looking at the 45-degree angles. And like I said, we need all 4 of them. So we get pi over 4, 3 pi over 4, let's see, 5 pi over 4, and 7 pi over 4. That would be the answers to that one. And number 3, we have cosecant squared x equals 4. So again, we would take the square root of both sides, and when we do that, we actually get the absolute value of that. And so we say that cosecant x is plus or minus 4. So, I'm sorry, plus or minus 2. I didn't take the square root, did I? And I believe that's a triangle we know also, because cosecant x is r over y. So the r would be 2, the y would be 1, and then this would be the square root of 3. So those are my 30-degree angles. And because it's plus or minus, it's going to be all 4 of them, the one in each quadrant. So x is pi over 6. This is 6 pi over 6, so the one back from it is 5 pi over 6. And then the one down from it would be 7 pi over 6. And then all the way back over here would be 12 pi over 6. So the one back from that is 11 pi over 6. And as I said, it would be all 4 of those because of the plus or the minus. Number 4, we have 2 cosine 2x equals 1. And so cosine 2x equals 1/2. And that's going to be in the first quadrant and the fourth quadrant. The 1 would be here, the 2 would be here, and the square root of 3 would be here. and that would be a 60-degree angle. Okay, and then it would also be in the fourth quadrant. So the way we do this is we say 2x equals pi over 3, and 2x equals, in the fourth quadrant here, this is 5 pi over 3, because 6 pi over 3 would be 2 pi. So 2x equals 5 pi over 3. And then we solve that for x by dividing by 2. So x equals pi over 6. X equals 5 pi over 6. And those are our two answers for that one. That's terrible. Okay. Moving on to number 5. We are supposed to graph y equals -2 plus 2 sine pi over 2 times the quantity x plus 3. So the period is going to be 2 pi over pi over 2, which is 4, which means I need to count by 1. And my amplitude is 2, and the domain is all real numbers, and I'll wait and pass judgment on the range once I see the graph. So here's my original set of axes, and let's see, 4, 5, 1, 2, 3, 4, 5, and then like I need to show what my scale is. Yeah, I don't know how to count. That should be a 4. That should be a 5. And then this graph is going to be moved down 2 and left 3. So I need to extend this a little bit. 2, 3, 4, 6. And then I need to show what that scale is as well. 2, 3, 4, 1, -2, -3, -4. Okay, and then my new set of axes, I'm going to move down 2. So this will be my horizontal axis. And then, as I said, I'm going to move the left 3. Get a different color pencil here to show that. Come on. So that's lovely. So that's my new horizontal axis, and then my new vertical axis will be here. Okay, and this is sine. So sine starts at the origin and then goes up from there. And so we'll go up 2 because the amplitude is 2. And we'll go just one space because I was supposed to count by 1. So I go up 2, and then I would be back here at my new axis. And then I would go down 2. And I would be back here at my new axis. And then I would be up 2. And back at my new axis, and then down 2. And then back at my new axis. And I need to go this way as well. On the quiz we took on this, a lot of you did not fill this in all the way, and I did take off a few points for that. When we're able to fill this in all the way because the numbers aren't crazy big or crazy small, then we need to go as far as we can. So I need to see more than just on the quiz. All I saw for some people is like that, and that's not going to suffice. You need to show, a full complement. I'm not saying you need to show 2 full periods, but you need to show, more than just one curve. Okay. Number 6 is y equals 3 minus 2 cosine quantity x plus pi over 4. Okay. This one's going to be a little tricky. So my period is 2 pi. Okay. Which means I need to count by pi over 4, which actually makes it not as tricky. I was thinking the period would be anyway, which is not going to be as tricky because I'm going to move it pi over 4. So it makes it less tricky or whatever. Like if I were going to move it pi over 2 and I needed to count by pi over 4, that's tricky. But it's the same, so we are good. It's not going to be that hard. Amplitude is positive 2. Remember, it's the absolute value of what's in front of here. And the domain is all real numbers. And I just realized I didn't tell you what the domain was up here. And it looks like my lowest point's at -4 and my highest point's at 0. So my range up here is -4 is less than or equal to y is less than or equal to 0. And as same thing, I'll reserve finding the range until I see the graph. Okay. And then this is going to take that graph and it's going to move it up 3 and left pi over 4. Okay. So I'm going to leave more space up top there. I'm going to bring this x-axis all the way down here. And counting by pi over 4. So 1, 2, 3, pi. Wait a minute. It is tricky as I thought. I'm messing this up, sorry. I need to count by pi over 2. 2 pi over 4 is how I determine what to count by. And that's pi over 2, not pi over 4. But I need to have pi over 4 on here because that's what I'm moving. Okay? So 1, 2, 3, there's 2 pi. 1, 2, 3, there's negative pi. 1, 2, 3, there's negative 2 pi. And if you want to mark, there's pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. And 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Okay. So my new axes are up 3. So I'm going to have my horizontal axis here. okay? And then left pi over 4, so my vertical axis is going to be here, okay? This is cosine, but it is negative cosine. So cosine usually starts up here and then goes down. Because the negative in front, the cosine is going to start here, okay? And I'm going down 2 because that's what my amplitude is. So because that negative, I'm going to be here, okay? And this is the part that's tricky. I'm not going to put my next dot right here because I'm supposed to have counted by pi over 2. So that means I'm going to go 1, 2 places, and that will be my next dot. And then I'll go 1, 2 places, and then I'll go up 2 from there. And then I'll go 1, 2 places, and that'll be here. And then I'll go 1, 2 places, and that'll be here. And then I'll go 1, 2 places, and that'll be back here. And going the other way, this would be 1, 2 places, I would be here. And then 1, 2 places, I would be up here. And then, see, that one was there. So 1, 2 places, I would be back on here. And so on. There's that graph, okay? All right, range. Looks like range is from 1 to 5. So 1 less than or equal to y, less than or equal to 5. That's all the stuff about that. Okay. Number 7. We have 1 over cosine pi minus, pi over 2 minus x. And that's one of those co-function identities. And really, all I need to do there is change that to 1 over sine x, because the sine and the cosine are the co-functions, and 1 over sine x is cosecant x. That's that. Number 8, we have 1 minus cosine x times the quantity 1 plus secant x times cosine x. I'm going to do a little trick here, and my trick is I'm going to leave this alone for right now. And you might think, well, I should FOIL these, but that's not what I'm going to do. I'm actually going to distribute this cosine x into here, okay? And when I do that, I get cosine x plus 1, because when you take and you multiply the trigonometric function times its reciprocal function, you get 1. Cosine times secant is 1. And then what I'm going to do, because I'm kind of, I don't know, needy, OCD, whatever you want to call it, I need this switched around to 1 plus cosine x. Okay, now I'm ready to multiply that out. So this is 1 plus cosine x minus cosine x is gone, and then that'll be minus cosine squared x, and that's the Pythagorean identity for sine squared x. Number 9, cotangent y plus tangent y over secant squared y. So a lot of times we look at it and we see, we see the tangent y and we see the secant squared y, and we think, use the Pythagorean identity on that, and we could probably arrive at the same answer, but because of that cotangent y over there, I'm going to change everything to sine and cosine instead. Okay, so the cosine is, cotangent is cosine over sine plus sine, tangent is sine over cosine, and secant squared is 1 over cosine squared. And so we did common denominator up top. We get cosine squared y plus sine squared y over sine y cosine y times cosine squared y over 1 when I multiply by that fraction. And then we've done this problem multiple times. Cosine squared y plus sine squared y is 1. This cosine squared is going to cancel with one of these. And so I have times cosine y, and then that's over sine y. And cosine y over sine y is cotangent y. And number 10, we have tangent A, cosecant A, cosine A. So I change everything to sine and cosine. So sine A over cosine A times 1 over sine A times cosine A over 1, and that's 1. Okay. Number 11, we have cotangent x equals tan x, and our domain here is 0 to 360, so we know that our answer is going to be in degrees. Okay, and there's a couple ways you can do this. You can change everything to sine and cosine, and then change everything to use your Pythagorean identity to get rid of the sine squared or the cosine squared when you cross multiply. You could also just change this to 1 over tangent, which I think is the simpler method, and then cross multiply. And when I cross multiply, I get 1 equals tangent squared x. And then you take the square root of both sides. Tangent x equals plus or minus 1. And that is a triangle, we know. 1, 1, square root 2, so that's 45 degrees. And then as we've talked about, because it's plus or minus, it's going to put us in all 4 quadrants. Okay? So I need 45 degrees. I need 135 degrees. That would be the second quadrant answer. I need 225 degrees. That would be the third quadrant answer. And I need 315 degrees. And that would be the four answers to solve that. Okay. Number 12 has log to the base 2 cosecant x equals 1/2. And to get rid of the log, we apply the definition. Remember, I always remember log base 2 of 100. I'm sorry. Log base 10 of 100 is 2, because 10 squared is 100. So cosecant x equals 2 to the 1/2 to apply that definition, or cosecant x equals the square root of 2. And again, that is a triangle we know. That's going to be the hypotenuse, or the r, the radius, is the square root of 2, because cosecant is r over y. And so this would be 1, and this would be 1. And that's a 45-degree angle. And for this problem, we are still in degrees. So x is 45 degrees. And then the other place that cosecant is positive is where sine is positive, and that's in the second quadrant. And that second quadrant answer is 135 degrees. Okay. 2 more. 13. We have cosine theta, tan theta equals cosine theta. And this is the one where you want to divide by cosine theta, get rid of it. Tan theta equals 1, 45 degrees. Good to go, right? No. You can't divide by cosine theta and get rid of it. You're going to lose one of your answers. So what we want to do is we want to cosine theta, tan theta minus cosine theta equals 1. And then factor out the cosine theta times the quantity tan theta minus 1 equals 0. I don't know where I got that one from. And then we can set each factor equal to 0. So cosine theta equals 0. Tan theta minus 1 equals 0. This is going to be a quadrantal angle. Where the x coordinate is 0, and that's going to be up here at 0, 1, and down here at 0, negative 1. And this is pi over 2, and this is 3 pi over 2. So for that one, theta equals pi over 2 and 3 pi over 2. And then for tan theta equals 1, we know that triangle. If you can tell, it's one of my favorites. 1, 1, square root 2. And so that's a 45. So theta is also pi over 4. But tangent is also positive in the third quadrant. And see, this is 4 pi over 4. So 1 down from that is 5 pi over 4. So that would be the answers to that one. And 14, last one. 8 sine squared theta minus 3 equals 1. Well, I'm thinking I need to add 3 to both sides. And then I'm thinking I need to divide both sides by 8. And then I'm thinking I need to take the square root of both sides. And I get that sine theta is plus or minus 1 over the square root of 2. So I added 3, I divided by 8, take the square root, and that is a triangle we know. Love those 45s. 1, 1, square root 2, and then because it's plus or minus, it's in all 4 quadrants. So theta is pi over 4. In the second quadrant, 3 pi over 4. In the third quadrant, 5 pi over 4. And in the fourth quadrant, 7 pi over 4. And that is it. Got questions? Make sure you come in and see me.